it's the 26th. Yes, please, April, go ahead.
From the package, can we do number 8B?
Yeah, so let's start with 8B as in boy. Yes?
Yes.
Okay, very good. So this is the chain rule combined with the power rule. So here we have 4x cubed minus 7x squared plus 12x minus 3 to the third power, and we want to differentiate. By the chain rule, I have to bring the power down. I have to subtract 1 from the power and multiply by the inner function prime. The inner function prime is 12x squared minus 14x plus 12. You're not required to do anything else. Any questions? I would like to continue with problem 7 and then choose the next. Questions on 8B as in boy.
So we use the power rule first.
Combined with the chain rule, yes.
Combined with the chain rule.
Yes, that's what it is, yeah.
And then we multiply by the derivative of it.
Right, because if you have x cubed prime, you will have 3 times x squared, but you should write times x prime, but it happens that this is 1. It's the same formula.
Okay.
But it's a function now. It's not x. Even x is a function, but it's not just plain x. It's the same formula. 3 times the function squared times the inner function prime. Better? Everyone? Okay, so let's look at problem 7 from the handout. So we have f of x, the square root of 2 minus x for x less than or equal to 2, and x minus 2 for x greater than 2. Is the function f of x continuous at x equals 2? So first of all, on this domain, 2 minus x, the square root of 2 minus x will be continuous. On this domain, x minus 2 is a linear function, will be continuous. So the problem is only asking us to see what happens at x equals 2. And x equals 2, I have to write the limit from the left of 2. Which function do I have from the left of 2? Very good. Does this equal the limit? I don't know. I'll come back and cross it out if it's not equal. So x approaches 2 from the right of which function?
X minus 2.
Very good. And does this equal f of 2? If all these 3 numbers happen to be the same, and all those limits exist, and all these 3 numbers are the same, then what will I conclude about x equals 2? The function is continuous at x equals 2. Okay, so let's find this number. How much? 2 from the left. 2 from the left is like 1.9, so it is 0 indeed. Good. And how much is this?
0.
And how much is this? And which branch will you use for f of 2? Top or bottom? Very good. 2 minus 2. 0. Since all these 3 numbers exist and they are the same, I will conclude that f of x is continuous on negative infinity to infinity. Everywhere, in other words, including at x equals 2. So I expect you to write a definition of continuity. I expect you to determine these numbers, and I will expect you to write whatever, continuous or not. Now the second part is extremely important and very important, very slightly more involved. Is the function differentiable at x equals 2? So we know that a continuous function may or may not be differentiable. If the function is differentiable, then the function is definitely continuous, no question. But there are continuous functions like the ones that have a corner. But at this corner, the function is 2 tangents, 1, 2. So it's not differentiable at that point. Or they have a cusp, not differentiable at that point, right? So, or a vertical tangent. So it can be continuous everywhere, but not differentiable everywhere. So here's what we need to do. Let's find f prime. And you could say, wait a minute, you haven't showed us whether the function is differentiable. How can you just go ahead and find f prime? Here's why I can go ahead and find f prime. I know that this is differentiable, and I will find its derivative. I know that this is differentiable, and I will find its derivative. What I don't know if this is differentiable yet. So I'll find the derivative of this, I'll find the derivative of this, and we'll analyze what happens there. So what is the derivative of the square root of 2 minus x? Let's do that on the side. The square root of 2 minus x prime is, what is the formula? When I differentiate a square root, 1 over 2, the square root times, on the side, the inner function prime. Right? So when I differentiate just this, I have 1 over the square root of x. But I should write times the inner function prime. I don't, because it's 1. But for this one, I will write 1 over 2 the square root of 2 minus x times the inner function prime, which is negative. Right? I'm differentiating 2 minus x, it's negative 1. Do you all agree with this? Yes? So it's negative 1 over 2 the square root of 2 minus x. Negative 1 over 2 the square root of 2 minus x. Can I write x less than or equal to 2? Look at what I just determined. Look at this function and say, yes, you can write x less than or equal to 2, or you can say, no, you cannot write x less than or equal to 2. I cannot write x less than or equal to 2, but what can I write? Why can't I write x less than or equal to 2? I'm going to write it and then erase it. So this is what I have here, right? So I copied it. But is it correct? No. What is incorrect here? Exactly. So I have to go back. I'm so happy they invented this. And I do this. So the derivative does not exist at 2. I can stop right there. But let's continue. The other side, the other piece. What is the derivative of this?
1.
Perfect. So 1 for x greater than 2. Any questions? Any questions? So the limit of from the right of this function, right of 1, right of 2. So let's look at limit of 1 as x approaches 2 from the right. What is it? X approaches 2 from the right. How much is the limit of a constant?
1.
Good. So let's determine the other one. Limit as x approaches 2 from the left of negative 1 over 2 the square root of 2 minus x. If this is also, if it exists and it equals what? Then I say that the function is differentiable.
It equals 1.
Exactly. If it exists and it equals 1, these two are the same, which means the function has a unique tangent there. From the left, the slope is, I should say this because it's 1. Yeah, 1. So from this side is 1, and from this side is 1. The same slope, not like this. From this side is 1, and from this side is 0.2. Then that is a corner, and it's not differentiable. But if both are the same, this side is 1, and the other side is also 1, then the function is differentiable at 2, and is differentiable everywhere on its domain. Okay, so let's see. 2 from the left. The denominator is 0. I shouldn't even do this, right? So I have negative 1 if you want over 0. There are 3 possibilities. right? We talked about 0 over 0. There is hope. Also, infinity over infinity, there is hope. But a number divided by 0, not 0 over 0, there is absolutely no hope. And the possible answers are these. Positive infinity, negative infinity here. So 2 from the left, 1.9, positive, but negative, and the denominator is 0. So what is the answer? For no hope, I have to choose one of these three because I have 1 over 0. However, we don't write DNE, do not write DNE because it's negative infinity. Finally, what do we conclude? What can you say? Although the function is continuous on all its domain, what do we conclude about differentiability? Non-differentiable at 2. And that's the final answer. Although continuous at 2, not differentiable at 2. F of x not from the right, what was it, from the left? Yes, from the right, the slope is 1. From the left, the slope does not even exist. Any questions? Next problem. Anything else you want? They are new, I just bought them. Yes, April?
Can we do number 10?
Yes. I just bought them yesterday, so they haven't been sitting in my purse.
They won't even go bad. Are you worried about that?
I think they do. At some point in time, some of them, the paper gets stuck on the drop, and you cannot even separate it. You have to wash them. So I think they do. And I don't think that they have the potency all the time. I forgot. What was it? 10? Yes. Very good. So limit 2 over x minus 2 when x approaches 2 from the right. Perfect example. This is exactly what we just did with a different function, and this time it was a derivative, and this is just a function. But this could be also a derivative. First, we have to plug it in. The top is 2. What is the bottom? Yes. So there is no hope. So it's 2 from the right. So we're going to plug in 2.1. This is still positive. 2.1 is positive. What is the sign of this with 2.1? The sign, just the sign. So the answer is infinite. Any questions? Yes, please.
How do you know it's infinity? If it doesn't.
Because a number over 0 has no hope, and it can be only one of these three. And since it's from the right of 2, I replaced every x with 2.1.
Okay.
When I replace every x with 2.1, since there is no negative sign, everything is positive, so this must be positive infinity. Better? Perfect. The next one is limit 7. Please put an x anywhere you want. You either want 7x minus 3 or 7 minus 3x. I'm sorry, it's a typo. Which one? It doesn't matter. You make it up.
Minus 3x.
Divided by x minus 1 when x approaches 1. So let's plug it in. What do we get? So please correct that. My apologies. So the numerator is good, and the denominator is good. So now I have a problem. Here's why. Because it says x approaches 1 from either side, I have to determine both. If one of them is 5 and the other one is 10, then it's DNE, which is not going to happen. It's 0. So infinity and negative infinity. Then I'll have to write DNE. infinity and infinity, then I would write infinity. Negative infinity and negative infinity, I will write negative infinity. So I know it's one of those three. So I have to find limit from 7 minus 3x over x minus 1 as x approaches 1 from the left, and limit 7 minus 3x over x minus 1 when x approaches 1 from the right. Of course, they both have something over 0. And they both have 4 over 0, to be exact. But the question is the sign now. 1 from the left means 0.9. This is still positive. But what is the sign of this with 0.9? Perfect. So the answer is negative infinity here. Here with 1.1, the top is still positive 4. But with 1.1 in the denominator, this is. So then the answer would be. Therefore, what would you write for DNA? I've got more. Want some?
It went down the wrong place.
Anyway, it's good. Good. Any questions? Any questions? Okay, anything else that you would like to work on? Anything else?
Can we go over 3 really quick?
Yes, 3. 1, 2, 3. Yes. So fixed costs, 23,000. Variable costs, 4.5 times x. Revenue. That's revenue. Variable cost. I'm sorry. Revenue is 7.5 times x, and they want us to find the cost function, the revenue and the profit, and the break-even point. Okay, so cost function is fixed cost plus variable costs. In this case, 4. So let me put a v in here, so you know it's not the cost function but the variable cost. Okay, so 450 x plus 23,000. This is the cost function. The revenue function is there, and the profit function is revenue minus costs. Please remember to remove or subtract all costs, meaning 7.5x minus 4.50x if you want, minus 23,000. So this ends up to be 3x minus 23,000. And now they want us to determine the break-even point. You either set equal the revenue with the cost, or you just set the profit equal to 0. So 3x minus 23,000 equals 0. X equals 23,000 divided by 3. Since they're cards, we cannot round them up. And just give me this number. Remember, the break-even point has this number of x, and this must be the revenue for that number. So that's how we present the break-even point. So when we divide 23, what is that? 7,000 what?
666.66.
How much? 7? Okay, perfect. So now give me the revenue. So multiply this number by 7.5. So this number times 7.5, I can do that too. $57,500. The reason why I did not get any decimals is because I did not use really this number. I used this number that I multiplied by 7.5. Multiply this number by 7.5, and I got that exact number. Good. Next question, please. I would like to look at number 4. In number 4, we have a function And my apologies, Amber, I just realized, April. We only looked at the denominator, we did not look at the numerator. Careful. We only focused on the denominator, which is wrong. Okay, so careful with that. Here there are two possible problems. This must be a real number, and for that reason I have to write what? 2x plus 4. No one likes the square root function. No one. I have yet to find one student who can say immediately 2x plus 4 must be greater or equal to 0, otherwise you cannot take the square root from it. It's just no one. No one. I have yet in 23 years of teaching, not one student likes this function. Not one student says, oh, it's a square root. You can take the square root from 0 or positive. So that quantity has to be greater than or equal to 0. That's all I want. That's my hope. And the second possibility, the second problem that we may run into is this. So remember, every time you see a square root, you must make sure that this quantity under the square root is greater than or equal to 0. Now, if it's in the denominator, it's only strictly greater than 0, not equal to 0, which we just had 2 minutes ago. Good. So we will factor the denominator, x minus 1, x minus 3. And we will solve the inequality as x greater than or equal to negative 2. We move forward and we divide by 2. So we know now that x cannot be 1 or 3. But in order to find the domain of this function, it is wise, or at least I will do it, to show what I'm doing, to show the path. So first I will graph this. I don't care for units. Negative 2 to infinity is this interval. But because x cannot be 1 and 3, I have a hole in here, and I have a hole in here at 1 and at 3. So coming back, now I'm able to write the domain of the function. Not this and this, the entire function. So can anyone give us the domain of the entire function?
So it's bracket negative 2 to 1 comma parentheses and then union 1 3 parentheses union 3.
Now you remember this from algebra. We've done this. Yep. Very good. What would you like to continue with? Yes, please, Chloe, go ahead.
Can we do number 5?
Yes. Please remember, yes.
Why can't it equal negative 2?
Say it again.
Why can it not be negative 2? Sorry.
It can. That's why it's a bracket.
Okay.
Negative 2, it can. Because of the equal symbol, it can.
Okay.
So please remember the average rate of change of a function is f of x2 minus f of x1 divided by x2 minus x1. We're given a function. All I have to do is plug them in. So I have age of w. So age of 60,000 minus age of 40,000 divided by 60,000 minus 40,000. I will not personally determine each and every one individually. I will put the whole thing in the graphing calculator and get one number. I'm not going to waste my time. So let's do that. So in parentheses, because you need parentheses around the numerator, I will put in, where is the function? 11.74. Oops. 0.74. And that's in parentheses again 60,000 raised to power 1/4 in parentheses. Say it again.
That's 600,000.
Oh. Thank you. Thank you. Very good. Thank you so much, Maddie. As you notice, I can't get away with anything when Maddie is in here. Just kidding. Just kidding. Thank you. Thank you. Thank you very much. Okay, and then 40,000. Close the parenthesis, caret 1/4 or 0.25, whatever you want to put. Come back down, close the parenthesis, and divide by 20,000. I can subtract 40,000 from 60,000. That's the only answer I care about. Be very careful. There is e raised to -4. Make sure you read the entire number. So the answer is 8.86. So the answer is 8.86 times 10 to -4. Measurement unit. This means nothing without the measurement unit. And now I read, oh, there is no measurement unit. Because this is not given as a particular function, and this is arbitrary, so abstract, I should say better. And otherwise, I would have had whatever measurement unit over whatever measurement unit. Because it's a rate of change. Measurement unit for the top will come from h, whatever the function is. Measurement unit for the bottom will come from those numbers. So that's all I expected to write, just one line. Okay, let's do 6. In 6 we have f of x, which is 2x squared minus 4x minus 3. And I'm asked to find the derivative using the limit of the difference quotient, which is the core definition of the derivative. But I can do whatever I want on my scratch paper, and I will find the derivative of this right away so I know what to expect. What is it? I'd better get this when I finish, right? It's also asking us to determine the equation of the tangent line to this point 0, -3. So how much will be f prime of 0? Good. So I can already determine the equation. Y minus y1 equals the slope times x minus x1, where the point is 0, -4, and the slope is -4. That's what we had, 0, -3. I'm sorry. -3. And the slope is -4. Although I did not finish, I have to determine this -4 using the definition. But I can already determine the equation. So this is y plus 3, -4 times x, or y equals -4x minus 3. However, I did not do what I was asked to do. So now I'll go back and do it. So I'm asked to use the definition, f prime, limit as h approaches 0 from f of x plus h minus f of x divided by h. When I'm done with this calculation, what do I have to get for sure as the answer to this? 4x minus 4. Andy, go ahead.
Isn't slope positive? Positive 4?
Oh, when x is 0, 4 times 0 minus 4.
Oh, that.
That's okay.
Okay. Oh. All right.
Is it okay?
Yeah.
Perfect. Okay, so now I plug it in. I recommend what I do with all my algebra students, but it's up to you. I recommend determine f of x plus h first. And then replace it in here. Or you can do it together in one limit. It's up to you. You want to simplify this on the side and then put it in, or you want to continue like this. It's the same thing, really. You want to continue as is? Okay, so I'm going to leave this for a moment. I'll come back to it. So let's find f of x plus h. So it's 2, what? Very good. X plus h squared minus? Very good. And minus 3. Now I have to be very careful. This you can distribute, but here you cannot. How come?
Square.
Exactly. You have to square first. Awesome. So then 2, and in parentheses.
X squared. That's H squared. So it's 2x.
Minus 4x minus 4h minus 3. I decided that if I start crying here, then you will remember. And
Well, since we've done it so many times and so many problems, I just put them all in order. Just X, H, and
okay, very good. Awesome. Yes, I agree. Well done. Good. So now I can finally continue. Limit sh approaches 0. I stop for a moment and I think. 2 things have to happen. I'm determining the difference quotient with the limit. Any term without h at the top must go away, and eventually h in the denominator, and then I'll get a function. Okay, perfect. So then I have 2x squared plus 4xh plus 2h squared minus 4x minus 4h minus 3. And now I'm here, and I have to distribute -1 to all 3 terms. It's better if I distribute than using parentheses and then writing it again, but I'm fine with either one. So -2x squared plus 4x plus 3. Is this okay? Everyone agrees with this step? Yes? Is this okay? So then I can simplify, cancel out, I should say better, 4x with -4x, 3 with -3. The remaining terms must have h in common. If they don't, I will never be able to cancel this or simplify this, and I'm not on the right track. Something is wrong. So the 3 remaining terms have h in common because everything without h went away. So then limit sh approaches 0. So let's factor out h at the top. So what is left in parentheses? Because this enables us to eliminate h. From the first term, 4x. From the second term, 2h. From the last term, -4. So 4x plus 2h and minus 4. I'm sure you, Brian, you remember all this from the previous class. Okay, so now, only now, yes, please.
Where'd you get the last 3 terms in the top one?
Minus the function. Minus this, minus this, minus this. Better? Good. So now, only now I can drop the limit operator because I say h approaches 0 and this goes to 0. So then I have 4x minus 4 as I expected from the beginning. This is the function that gives the slope of the tangent line to the graph of the original function at any point possible. Why? Because it's quadratic and it's always differentiable. Always continuous. No cusp corners, vertical tangent, etc., etc. Any questions? But since we already knew formulas, differentiation rules, we already differentiated and we got the equation. It was all done by the time we determined. And yes, we also did what we were asked to do, find the derivative using the definition. But we were way ahead. Yes, please.
Where did the 2h go?
Can anyone tell us where the 2h? It's the best thing to do is to teach somebody else what you learn.
You plug in the 0.
Right?
From
H approaches 0, right? That's always the case. I think I mentioned that to you. The best professor I've ever had in my entire career is a professor at UMBC. He's of Indian descent. His name is Gowda. I can't pronounce his first name. I can't tell you. But he's the best professor I've ever seen, I've ever taken a course from. The best ever. And I asked him, I said, how did this happen? And he said, when I started teaching other people, I finally realized and I understood what I learned before. Because I didn't even, he couldn't connect some topics he said sometimes. But then when he started teaching, everything started clicking in his head. So start teaching anyone these topics, anyone. I'm not kidding at all. That's what he said, and I realized that. That's true. You really start understanding topics when you teach somebody and you explain to somebody. Very good. So that's why sometimes there is no, don't take it personally or anything, but it will help each other if somebody else answers. Okay, good. What else we would like to look at here?
I'd like to see 9.
9 it is. Very good.
A little off topic. Did he retire about 8 or 9 years ago?
Gouda? I don't think so. He's in his 80s, but I don't think he retired. Yeah, he's in the math department at UMBC. Fantastic, professor. So this or dy over dx, same thing. We bring down 2/3 and we subtract 1 from the power. 2/3 minus 1, negative 1/3. And this is the first derivative. The second derivative, d2y over dx2, in other words, we differentiate y with respect to x the second time. That's all it means. We bring down negative 1/3, so this is negative 2 over 9, x, negative 1/3 minus 1, negative 4/3. And that's all you have to write.
It's on the right track.
Yes, I'm sure. Yes, please. April, go ahead.
Can we please do 8D?
Only for you. I'm not kidding. You said 8D as in dog? Very good. Good. Let's do that. It's the same thing with any power. 3 minus x minus 2x to the third. This is raised to 1/3. We bring down the power. We subtract 1 from the power. And we differentiate the inner function. Negative 1 minus 6x squared. And you don't have to do anything else. Okay, I just typed up his name. So it's Mudappah Sitarama, I want to say.
That's cool.
Yes. So that's his name. So he got his PhD in 1982. Your parents were not born in 1982, probably. He's a fantastic professor. That's all I can say. And I don't think he retired. I don't.
I need to update that website. That's where it says 2007. That's cool.
Good.
To go back to the,
Yes.
is it gonna be worded just like that in the other one?
Which one? Which problem are we looking at?
All of them? Like they're all gonna be worded this way with different numbers, right?
So, well, I will look when I write your exam. I will look at what we did in class. So the wording, yeah, I mean, find the derivative. That's pretty much what it's going to say. Find d2y over dx2. Find the limits. Yeah, I mean, I don't know what else I could say. For the given function, find the average rate of change. Use the limit of the difference quotient to find. Yeah, I mean, I don't want to say yes for everything, but I just want to make sure. Yes, Maddie?
Oh, sorry. Can you do 2, or can you explain 2G?
2G. Oh, you just have to graph the function and find to show whether the function is continuous at 3 by finding writing the definition of continuity of the point. The limit from the left equals the limit from the right equals the function.
Okay.
Yeah. Is it continuous at a point? Then you have to show the definition of continuity at that point. Anything else that we would like to look at?